Hey guys, no fooling, it's April 1st today. Yuck, yuck, yuck. So we're going to be talking about a second shape today. Area of a triangle. So lesson 9-2, area of a triangle. And I'm not joking when I say it's half as much as a parallelogram, and you'll see that. Plus you'll get a little magic act in class again. So today's date is 4/1/19. Okay, so remember we had a parallelogram. And a parallelogram had the area was equal to, well, let me try that again. Let's write the formula down. Area of a parallelogram was base times height. Now this also works for rectangles. Same formula. Because it turns out with a rectangle, the base is like that bottom of the parallelogram and the height is the left side. Since it's rectangle, it's at a right angle to the base, the height is. So what we find out though is that the parallelogram, when we go to a triangle, and I can draw a little bit of a picture over here. Since a rectangle is a parallelogram, and that formula works, if I cut on a diagonal from a point to a point, or as we say in geometry, vertex to vertex, basically what I do is I create two congruent, oops, let me try that again, triangles. So this side is congruent to this side is congruent to this side is congruent to this side, and it all matches up. Okay, so the formula for the area of a triangle is going to be 1/2 that of the area of a parallelogram. Okay, so that's the area of a triangle. And I like to use the symbol of a triangle. Okay, so again, we're going to mention that word congruent. Very, very important word for geometry. It's not the same thing as being equal, because it's not the same exact figure. So this is going to be figures that have the same shape and same size. Okay. In other words, they're identical. Now, let's think logically about this. If something has the same shape and the same size, then doesn't it stand to reason it would have the same area? I think so. Okay. So we're going to do two examples. I think we can fit them on this page. We'll see what happens. So kind of short notes here today. One is going to ask us to find area, and one is going to ask to find the missing dimension. So find the area of the triangle. And just like with a parallelogram, the base is the bottom of the triangle, and the height is perpendicular to it. Now, sometimes you can get a height that's outside the shape, sometimes inside the shape. So let's draw a little figure. And let's draw in our height. And we're going to label. This guy is 12.1 meters at top. This guy is going to be 6.4 meters. And remember, when you have a line that's perpendicular to the base, he's called the height. Okay, so we're going to go ahead and start with our formula, and I always write the formula first because I'm trying to learn it. And we're going to plug in the pieces we know. The base, is not 2.1, it's 12.1. And the height is 6.4. Okay? Now, I get to multiply the height, let's try this again, the half by one of those terms. So if you can see a term that's an even number, I'm going to take half of it. So if you think about the associative property of multiplication, it says we can change the order of what we multiply, and it will not change the answer. So mathematically, what I'm going to do first is take half of the 6.4. So remember what that really is just dividing by 2. So 2 goes into 6 3 times evenly, decimal point, and 2 goes into 4 twice. So now what I have is 3.2 times 2.1. So I'm going to do the math over here, and I'm going to temporarily forget about decimal points. So it's just 21 and 32. So I get a 2, a 4, a 2, a placeholder. I get a 3, a 6, a 3. I get a 2, I get a 7, I get an 8, I get a 3. And let's see, there was 2 digits after the decimal point. So I get the area was 38.72. So the area is 38.72 square meters. Okay, so let's do one with a missing dimension. So it says find the missing dimension. And by the way, you're expected to memorize these formulas, okay? Very important. Certain things just need to be in your head. We need to use them that much. Of the triangle. So let's see what they give us in our diagram. So this is a special triangle called a right triangle because its largest angle is a right angle. And let's see what information they give us. Oh, they tell you this. This is 6 centimeters. This is B. And they're going to say A equals 24 square centimeters. So it looks like that 6 centimeters plays the role of height since we've got a B over here. So we're going to go ahead and write the formula. Area equals 1/2 base times height. And then I'm going to start substituting numbers in. So we've got 24 takes the place of the A equals 1/2 and a B, and then we have the H is 6. Okay. Now we've got a couple choices. We can take care of doing the inverse of multiplying by 1/2 and then the inverse of multiplying by 6. We could do that, or we could try to simplify. So it's the same sort of idea that we did before, where I'm going to use the associative property of multiplication, and I'm going to take half of the 6. So if I do that, I get 24 equals half of 6 is 3, and I get 3. I'm sorry, I keep drawing so sloppy these days. Let's try that again. Is 3b, and then the inverse of multiplying by 3 is dividing by 3. Now I did see a couple people on the last couple tests when they were trying to get a variable alone, they divided by the variable. The variable you don't do anything with. You do the inverse operation of the number that is having math done to the variable. Okay. So I'm going to do the symmetric property. Remember what that does. It takes the right side, 3b divided by 3 is b, puts it on the left. 24 divided by 3 is 8, puts that on the right. So b stands for base, so our answer would be the base measures 8 centimeters. And that's it. That's all you're going to be working on. That's it. 10 minutes. Yes! Have a good night, guys.